Hello everyone, my name is Ram Shreyas and beside me is Surya Tej. So we are going to do a video on PPT on physics, electric current and its effects. So let's start. Physics, electric current and its effects done by Shravan Surya. What are we going to grasp? Electricity, fuse, cell and battery, switch, bulb, wires, types of symbols in electricity. Electricity. Electricity is a set of physical phenomena associated with the presence and motion of matter that has the property of electric charge. Electricity is related to magnetism, both being part of the phenomena of electromagnetism as described as Maxwell's equations. Various common phenomena are related to electricity, including lightning, static electricity, electric heating, electric discharges, and many other. The presence of an electric charge, which can be either positive or negative, produces an electric field. The movement of electric charges is an electric current and produces a magnetic field. Over to Surya.
Fuse. In electronics and electrical engineering, a fuse is an electrical safety device that operates to provide overcurrent protection of an electrical circuit. Its essential component is a metal wire or a strip that melts where too much current flows through it, thereby stopping or interrupting the current. It is a sacrificial device. Once a fuse has operated, it is an open circuit and must be replaced or rewired depending on its type. Over to Shravan.
Cell and battery. A battery can be defined as an electromagnetic device consisting of one or more electromechanical cells which can be charged with an electric current and discharged whenever required. Batteries are usually devices that are made up of multiple chemical cells that are connected to internal inputs and outputs. Batteries are widely employed in order to power small electric devices such as mobile phones, remotes, and flashing lights. Historical, the term battery has always been used in order to refer to the combination of two or more electromagnetic chemical cells. However, the modern definition of the term battery is believed to a common device that only feature is a cell, single cell. Auto Surya.
Switch. In electrical engineering, a switch is an electrical component that can disconnect or connect the conducting path in the electric circuit, interrupting the electric current or deriving it from one conductor to another. The most common type of switch is an electromagnetic device consisting of one or more sets of movable electrical contacts connected to external circuits. When a pair of contacts is touching, current can pass between them, while when the contacts are separated, no current can flow. Over to Shravan.
Bulb. It is a device that gives light when we power it with battery or other electrical component it has. Over to Surya.
Wires. Wires are power lines that pass electricity through them. They have copper inside a rubber tube. The rubber tube helps to keep the electricity inside so it won't short circuit or touch any other objects. Over to Shravan.
Types of electric symbols. Lamp, wall light, light, globe, switch, locking switch, push button switch, wire, connected, not connected, voltmeter, ammeter, galvanometer, potentiometer, galvanometer, capacitor, polarized capacitor, variable capacitor, crystal, diode, photo editing, LED, diode pin, cell, battery, ground, fuse, do supply, no supply, resistor, variable resistor, transformator, antenna balanced, speaker, microphone, heating, suspend, motor, electric bell. Let's watch how to make some circuits. So I'll be going to Tinkercad.
which is a website. Tinkercad is a website.
So let's see. First, we'll learn how to make a normal
Simple circuit.
simple circuit. We'll use one cell battery, a LED, and we'll use a resistor. So let's start. The positive cell goes to the resistor as terminal 1 and terminal 2 goes to anode, which is positive, and the negative cell negative will go directly to the cathode, and yes, it is black. So let's start simulation. As we can see, the LED glows, which means the power is working, and this is a simple circuit. We can use different batteries such as a 9-volt battery,
9-volt,
a switch, and a lot more.
even a
Or
breadboard.
even a 1.5 volt battery too.
Volts. And we can even do a breadboard.
We have breadboard, motors, DC motors, and a lot more. Now, for second thing in it, let's make a different circuit now.
Shravan, your voice is breaking and your video is paused.
So let's make another circuit. So we have draw the circuit diagram to represent the circuit shown below. So first, let's just make we already saw a simple circuit. So let's make a combination of circuit batteries and make LED. So let's start. So we'll take a 9-volt battery. Well, we'll take two 9-volt batteries. And we'll take a switch. Well, not a switch, any LED. So let's connect the wires. The negative cell goes to cathode, which is the long straightened strip on the LED. We can use switch if possible, but I'm not going to use any switch here. We'll change that color to red. Anode. Anode means positive. So let's start simulation. So as you can see, the LED is glowing more than expected.
Brighter.
So now, as you can see, it's glowing more. And if I remove this cell, then it and start the simulation again, then it glows only a little. So we can see current through the LED
The higher
MA,
the higher the power.
maximum is 20.0 MA. So we'll stop simulation. And next project, we'll use other capacitors like we'll keep a DC motor this time and remove this LED. So let's start. So yeah, I'm connecting negative to negative and positive to positive. So as you can see, when I start simulation, there is a number over here which is 17568 RPM. So
17,568 RPM.
So our next project, so I'm gonna delete this and come out of the site and go in it again. So we have different types of circuits and lessons. So we are going to take motor rotation with battery. So tinker this. So here we used components such as battery,
breadboard,
breadboard, TP120, TIP120, and
5 volt,
two DC motors, a breadboard, some connection wires, and two IR sensors. So, what is an PIR sensor? So, a PIR sensor can move or project whatever we want. So, let's see. Now, see carefully. If I click on the PIR sensor, if I start simulation and then click on the PIR sensor, then a blue dot comes here. So we observing on the motor, there is a 0 RPM over here, and when I move the blue object, it becomes to 120 RPM. So that means the motor on top is working. And now let's go to the motor on second motor. So as you can see again, I'm just gonna move the blue object,
zoom out.
and it's as
As you
120
can see,
RPM. So that's how it works. As you can see, these are a lot of components, and it's actually a little high. So we have other like symbols and all, and then we have anode symbol and all, as you already saw. So that's it.
thank you for watching our presentation.
Thank you for watching our PPT and the circuit making. Hope you learned something. So thank you and bye bye.
You